Alright guys, you're welcome to my next tutorial. Today we shall be looking at insertion sort. Insertion sort is one of the sorting algorithm. Let's take a look at this array. Let's say we have this array, and how does insertion sort go about sorting this array in non-decreasing order, that is in ascending order. So the intuition behind the insertion sort is that the first element in the array is sorted. So if we check in this array where we have 832975154, so the first element is assumed sorted. Now we move to the next element, which is 3. Now we compare the second element 3 with the first element. If the second element is less than the first element, then we swap. So as in this case, we swap. So 3 8, it becomes 3 8. Now we move to the third element. Now if the third element is less than the second element, the third element now is 2. So we compare the third element, which is 2, with the second element. If it is not already sorted, we swap. So it becomes 2 8. Then still in that same session, at that same iteration, at that same looping, we compare 2 again with the first element. If it is not in place, we swap. So that is the procedure. We swap. Then we check if our index has already reached the boundary, that is, it has reached 0. If it has reached 0, then we exit the loop. Then we go on to the next element, which is 9. So the next element is 9. Then we compare 9 with the previous element. What is the previous element? 8. If it is not sorted, then we swap. Then in the same iteration, we compare 9 with the previous element. If it is not sorted, we swap. But in this case, it's already sorted. So once it's already sorted, then we leave it. We exit that iteration. Then we go on to pick the next element. The next element now is 7. So we pick 7 and we check whether we compare 7 with the previous element. The previous element in our sorted array, we always compare with the previous element in our sorted array, not in the original array, because now this is sorted. So we compare 7 with the previous element, which is 8. We check. If it is not sorted, we swap. Then in that same iteration process, we check 7 with the previous element. If it is not sorted, we swap. Then we compare 7 with the previous element. If it is sorted, then we exit that iteration. Then we leave it as it is. Then we continue again to pick the next element, which is 1. So we pick 1. We take 1 and compare with the previous element in our previous element in our sorted array. If it is not sorted, we swap. Then we compare 1, the current element, with the previous element, with the next previous element. If it is not sorted, we swap. So this becomes 1 9. Then we compare again 1 with the previous element. If it is not sorted, we swap. Then we compare 1 again with the previous element. If it is not sorted, we swap. Then we compare 1 again with the previous element. If it is not sorted, we swap. Then when we try to compare 1 again with previous element, since there are no more previous element, we exit the loop. So that is the process of insertion sort. And you can also do the same thing for 5. By the time you do the same thing for 5, we compare 5 with 8, with 9, with 7. Eventually 5 will be compared with 3, and you exit the loop, and it will remain here after a number of swapping, after 3 swappings. Then you can also take 4, compare 4 with 8, you swap, with 9 you swap, with 7 you swap, with 5 you swap, you compare with 3, then you exit the loop. Then your last swapping is the last one with 5. So that is the intuition behind the insertion sort. So let's see an implementation in Java. So this is isort. It takes an array. And we check the length of the array. If the length is less than 1, we don't do anything. We are only interested when our array has more than 1 element. If it's just 1 element, then it's sorted, so we don't need to do anything. So then we go through the for loop. We iterate through the entire array starting from the second element. Since our I is actually, our array starts from 0, so I equals to 1 will be the second element. So we start from the second element. We put that second element in a temporary variable. So, and we make I and j we declare j as a new variable, and we make it to be equals to I. You will see reason why we have to declare this variable temp and this variable j in the next slide. Now you will see that here we are making use of the variable j to be able to do our comparison. We are not making use of the I, and the reason is because temporarily we want to be able to use the current session. The current value that we are trying to sort is the value of I. That is the current value that we are trying to sort. That is the value of I. That is what I corresponds to in our array. And so we take that current value, we put it inside j, the index of that current value, we put it inside j. Then we use j as if it's our I to be able to do the swappings that we need to do. And with the help of this temp, we'll be able to store the intermediate values in temp. And that's what is happening here. So a of j is just like a of I, and we compare it with the previous, that is a of I minus 1. So in this case, when our I is 1, if a of I, that is a of I, is less than a of I minus 1, that is we have a sequence 2 3, or we have 3 2. So this is our I, this is the current value, this is I minus 1, or you can say this is our j, current value, so this is j minus 1. So we compare it with the previous. If it is not sorted, then we also check and make sure that our I is, which is our j, is greater than 0. We want to be sure that it's greater than 0. The reason is so that we will not run into array index out of band error. So if these two conditions are satisfied, then we put the current value of a of j, which we have already done here. Still the same thing we're doing here, so we might not necessarily need to redo this one, but still we put the value, the current value of a of I, which is our a of j, into a temp. Then we replace the value of our a of j with a of j minus 1. So this means if you have 3, 2, now a of j in this place is 2. A of j minus 1 in this place is 3. So I am saying replace the value of a of j, which is 2, make it the value of j minus 1. So this one will become 3. So this becomes, our array becomes 3, 3. In a way, we have lost the 2. But thanks that we have kept the value of our 2 in our temporary variable. So our 2 is in the temporary variable already. So then when we're through with that, then we put our temp, which is our 2 now, into a of j minus 1. So this is j minus 1. So this becomes 2. So that is our swapping process. Then we decrement j by 1. Then we check again whether j is greater than 0 and j minus 1 is less than a of j is less than a of j minus 1. If this is true, we repeat the same process until it's going to get to a point when is either a of j is greater than or it is equals to a of j minus 1, or j is greater than, j is equals to 0 or j is less than 0. It's going to get to that point, then we exit this loop. That is the main point. And we can look at what happened in that scenario with what we explained before. Let's say, for instance, we have 8, 5, and we have 1. We know that for this to be sorted, 1 is supposed to be the first and followed by 5. So the way it's going to go, so we have 8 is the first element, we assume is sorted. Then we take 5, which is our current j. We compare it with 8. Then we discover that it is not in the sorted position. Then we swap it. Then this becomes 5 and this becomes 8. Remember, we still have 1. Then we increment our I from 5, it comes here. So our I comes to this place where we have 1. Then we go again into our for loop, into our while loop. Now we check, is our a of j, which is this, is it less than our a of j minus 1? We swap. So this one becomes 1, this one becomes 8, this is still 5. That is at the first iteration. Now because we have changed the value of j, we have decrement j. So this a of j becomes a of j minus 1, and this a of j minus 1 becomes a of j minus 2. So this is now a of j, this is now a of j minus 1. So we compare 1 with 5. It's not in place, we swap. So this becomes 1 and this becomes 5. Now we decrement our j again. Now our j is decremented, and at that level, when we decrement our j, remember that our j is 0 here. By the time we decrement our j again, this condition will no longer be satisfied. We discover that our j is no longer greater than 0. Our j is no longer greater than, at this point, when we get to this place, our j is 0. By the time we decrement it, it becomes minus 1. So you discover that our j is no longer greater than 0, and this will terminate. And so that is just what happens there. And that is you can find the code on our GitHub page. The time and space complexity. The time complexity is n squared. The space complexity is constant. The space complexity is constant. So we can just make a change of that. the space complexity is constant, so this is supposed to be constant. We're not using any extra space, so the space complexity is constant. So so that is constant. Now the running time when we have a best case is n, and we have a best case when our array is already sorted, and that means that we will not need to enter this while loop. It means once we get into this place and we do the comparison here, this one will fail, then I will increment again to the next one, then we compare, get to this way, we make a comparison, this will fail, then I will increment to get to the end. So in our best case, we only go this one only n times, we only iterate through the for loop. But in the worst case, we iterate through the for loop with the while loop. So each time we go the for loop once, we go the while loop at most n times if we have a reverse sorted, if it is reverse sorted. So we have to do the swapping n times, and so by the time we go through these n times, and this one will be n times, so it becomes n squared. So that will be our worst case scenario. So in the worst case, it is n squared. So thanks for listening. Your comment is well appreciated. You can see the code implementation on our GitHub. Thanks, and see you in the next tutorial.